Utility overview for the Grenada AI Energy Campus. The Grenada AI Energy Campus runs on a standard playbook, repeatable building footprints, and copy-exact utility kits. Loops sit in the grass utility grid with sectionalized tie points, so crews follow the same steps pad after pad. Shorter routes, fewer pavement cuts, faster phases, and a predictable O&M. A low-water central plant that leverages secondary chiller heat for efficiency completes an overall design providing high availability without complexity. Electric private wire. Power is private wire AB, fed from on-site substations to building pads through the grass utility loop. We use switches at nodes for safe isolation and keep feeders out of pavement wherever possible. Recip modules provide approximately 100 megawatts per building of N+1 backup, with fast ramp while the combined cycle plant builds out. Fiber. Each data hall has 4 standardized fiber entries at the short end of the building. Dual, diverse laterals ride the same grass corridors to tie into regional POP/IXP points. The result is low latency reach with less change order risk and clean, repeatable splicing at standardized vaults. Natural gas. 3 Columbia Gulf lines on site supply a looped header to the recip yards, with the combined cycle M and R station dual-fed from opposite ends. Routing stays in the grass utility corridors where possible for easier access and minimal paving work. Chilled water supply and return. Cooling is centralized and low water by design. We loop chilled water supply/return to the data halls and reuse secondary chiller heat where it helps. Using dry hybrid equipment trims water draw and delivers about a 10% reduction in cooling energy versus conventional evaporative plants, fewer chemicals, fewer visible plumes. Water and industrial water/fire. Water service is looped where required with standardized vaults, meters, and taps at building pairs. The elevated tank stabilizes pressure and supports redundancy with treatment integrated near the combined cycle plant. Keeping mains in grass easements speeds repairs and avoids pavement demo. Fire water is served by dedicated ground-level firewater storage tanks, with the site's elevated tank providing system pressure and redundancy. Mains stay out of drive lanes, so access remains open during an event. A dedicated fire ring serves hydrants and FDCS with sectional valves for maintenance. Sanitary sewer and force main. Industrial wastewater, sewer, and force main. Sanitary service is gravity-fed from the data halls and combined cycle plant into the park's existing American Way sanitary sewer. The only pumped segment is a short force main from the water quality plant back into the gravity line near the gas yard. Industrial wastewater follows the same path toward American Way, then is pumped to the water quality plant. Building stubs tie into sanitary and industrial wastewater mains in the grass utility loop, not through paved yards. Industrial/process water is treated on-site at the water quality plant and reused for cooling and non-potable needs. Only permitted surplus, if any, leaves the loop. Final routing set in detailed design. Industrial/process water is polished at the on-site water quality plant and recirculated for tower makeup and non-potable uses. With optional water quality plant expansion and blowdown recovery, the campus could cut cooling energy approximately 10 to 18% and potable makeup approximately 30 to 60% versus a conventional plant. In summary, the Grenada AI Energy Campus is compact and gridded with copy-exact utility kits and grass-rooted loops, delivering shorter runs, faster installs, and easier maintenance, paired with a low-water central plant that reuses secondary chiller heat. It's why Grenada qualifies as one of the most power-dense, fully integrated AI campuses in the U.S.